Alright, welcome back to chapter 11 with on integration. Two exercises we'll cover today. 11G will be integration of circular functions, and 11H will be sort of application with already known anti-differentiation, but in a way that it's more worded problems, or more a combination of several strategies. All right, first with circular functions. So do remember, you should remember how to differentiate your circular functions. The antiderivative is the inverse process. So when you anti-differentiate a sign, that will be a negative cos. The antiderivative of cos will be sine. And as it is here, they combine all that rule into in a general formula. When you have a sine or cos of a linear function, which is mx plus c or kx plus a, you would add a factor 1 over k of the cos and sine of that linear function. So it's proven using a chain rule. You just need to familiarize yourself with the rule and apply it accordingly in various situations. Two examples. First one, you have cos of 3x. So you need to do the integral of cos of 3x dx. That antiderivative has a 3, which is your k. 1 over 3 sine of 3x. Don't forget the brackets. Good practice to have a neat notation, and plus c as it is the general solution. Second, we apply the antiderivative. Do remember here it's a definite integral. So when we anti-differentiate sine of x, that gives us negative cos of x. Do be thorough with the square brackets. On the right hand side, do write the lower and upper boundary. As you substitute with the lower boundary, do not forget the bracket. Again, it's good practice. As your functions might get more complex, you by not being thorough, you will make a mistake and end up with the incorrect answer. And here we get the solution, simplified and sort of factorized. Doesn't really matter which one you pick, that's fine. All right, moving on. Let's look at two examples. First one, you should be kind of exposed to that. When you have a square root or any root, turn it back into a polynomial. You may end up having negative power or fractional power. In this situation, you have a fractional power of 1 over 2. As you anti-differentiate, which you know by the square brackets around, it's a half plus 1. Turn it into an improper fraction, which is 3 over 2. As you divide by 3 over 2, it's the same as multiply by 2 over 3. So what I would do here, as you divide by 3 over 2, it's actually multiplying by 2 over 3 times, it's the x to the power 3 over 2, which is your 4. Let me write the working out. 4 to the power of 3 over 2 minus basically 1. 1 to the power 3 over 2 is 1. Okay, so to be thorough, I write it here, but it just simplifies to 1. Again, what I mentioned, I did tell you to put brackets and I wasn't doing it. Okay, so don't forget to put the bracket here. So here, that's you apply square root. You can do it on the calculator. So that's 8 minus 1, that's 7. 7 times 2 gives us 14 over 3. All right, last one. Here, you want to find the definite integral of that function. The way it is, you do not know how to do this, so they break it down into, they starting a first step, which is differentiating this function. As it happens, when you differentiate, you're going to end up with that same sort of expression. So here, first part, let's differentiate that. So it's e of x to the power of 1 over 2. So using a chain rule, you should know how to differentiate that. So it's a function of a function. So the square root will give you a derivative of u minus, hang on, I'm not really, yeah, okay, sorry, my bad. You differentiate that, that's square root, so that's 1 over 2 factor. The new power, it's the square root, is 1 over 2 minus 1, so that's x to the power of negative 1 over 2. And the exponential, the derivative of exponential is itself, so it's of that function. As you regroup it and you turn the negative power into a positive, it's that function, which is equal to, if you have that function, is exactly that one. So to make that function a subject, we multiply by 2, so it's going to be 2 times the derivative. So you substitute this function by either you substitute or you introduce a factor 2, so you end up with this one, and that antiderivative, because we define as the that answer, sorry, this one, which is the same as this one, okay, that's the same as that one. So if I make that as the derivative of whatever I have in there, the derivative and antiderivative, they cancel out. So what you need to do now is rewrite. So you have a factor 2. That integral with the derivative simplifies to the square brackets, which is e of square root of x. And don't forget the boundaries, lower boundaries from 1 to 2. So don't forget about that. When it's a definite integral, so even if you have a derivative in here, it cancels out. Don't forget it's a difference, so it's from 1 to 2. Then you substitute the x value by the boundaries and you get the final answer here. All right, that's it for those exercises, and enjoy solving those questions. See ya.